let's start with the new topic, which is functions. And I want to know in the chat, how many of you have started functions at school? So yes, if you have, no, if you haven't. And then welcome to Gundo, Lekonolo, Mussolini, Sange, Silikani, and Stephen. Welcome. It is good to be with you. So let's see. Everyone has started, and some people have even finished functions. Oh my goodness. Okay. So we're going to do our best to make things interesting today by kind of doing a little bit of an overview of the four main functions that you deal with in grade 11. So the first function that I know you all have spent a lot of time with is y equals mx plus c, which is a straight line. And an example of this would be something like 2x plus 3. Okay? Now, what we have is that is a straight line, and the values that normally come into play are that m is the gradient and c is the y-intercept. Okay, so that's the important stuff. Let me just ask you this question, though. If I had to say to you 2x plus 3y equals 4, is that a straight line or not? Let me know. Is that a straight line? It doesn't look like y equals mx plus c, but I want to know from you, is that a straight line or not? And how would I know whether that's, what do I need to, how do we kind of know that that is a straight line if I tell you that all straight lines look like this? Okay, Sange has said it's not in standard form, and you're absolutely correct, Sange. I can rewrite this in standard form if I move the 2x to the other side. Still not in standard form yet, but then I divide both sides by 3, and this whole thing is over 3, and it's still not in standard form yet. But if I do this, that's standard form. And so this is in fact a straight line over here, but the gradient is minus 2/3, and the y-intercept is 4/3. Okay. If I had to visually draw this straight line, I would need 2 points to draw it. The 1 point is the y-intercept, so it's going to be 4/3. So I'm going to put that there. That's 4/3. But I need another point to draw this straight line at the bottom. What we normally do is we find the x-intercept. How do we find the x-intercept with straight lines normally? What do we have to do to find the x-intercept? What's the process? Because if I've only got 1 point, I can't draw my straight line. So there's something that I need to do to help me find the x-intercept. To find the x-intercept, I make y0. That's it, yeah. I make y0. And so let's actually see how this works. So I've got my equation of my graph down here. So y equals this. If I make y0, then I'm going to get minus 2/3x plus 4/3. Or do you know what I could have done? I could have actually just put it back into the original equation. Why am I dealing with the difficult one? Let me not be a nana here. Let me rather put the 0 in the original equation, which is over here. Now, what is the value of the x-intercept going to be? So using the blue writing, what is the x-intercept going to be for this graph? Pop your answer in the chat or put your hand up. You can tell me audibly. Both are fine, but I just want to get some sense of that. So 2x plus 3 times 0, this actually is not going to do anything. So I'm just going to have 2x is 4, in which case, what does x have to be? X has to be 2. So the x-intercept would be 2. And so what would the straight line look like? Let me just actually draw in a different color. So let's say blue. I should have put my 2 a little bit to the left there or something. But that is what the graph looks like. Give me a thumbs up if you followed that. Give me a thumbs down if you didn't. I'm going to move on to parabolas now, but I just wanted to do a quick little bit of revision on straight lines. Okay. So the next most important function for grade 11 functions is what's called the parabola. And the most basic parabola that you can get is y equals x squared. But the standard form of a parabola is ax squared plus bx plus c. Okay, so that's like we have mx plus c for straight lines. For parabolas, or the graphs of quadratic equations, they look like this. Now, a parabola like, let me draw you 2 different parabolas. So let me give you an actual example. This is going to be 2x squared plus 3. And then on this side, I'm going to have y equals minus 3x squared minus 4x plus 7. These are both quadratic equations, and they have parabolas as the graph because the highest power of x is a power of 2. But they look quite different. This one on the left doesn't have a linear term or what's called a middle term. There's no term that has just x. There's only the x squared and the c term, whereas these have all 3. I want you to tell me what else is different about these 2. So we know they're both parabolas. What is different about them from your things that you've learned in class? What do you know is different about them? Pop your answer in the chat there. Ah. Okay, I was thinking about this thing in front, the A value. Can you see that's positive there and it's negative there? What effect is that going to have on these parabolas? Now, the parabola, if I haven't given you the basic shape, I'm assuming you've seen it in class. The parabola shape is either like this, I call it happy, or it's sad. Okay, that's the basic shape of the parabola. It looks like someone's face smiling, and you can have a wide smile, or you can have a narrow smile, but essentially it's like a happy or a sad shape. What effect does the 2 have on this parabola? Is it happy or unhappy? Pop your answer in the chat. So is the blue graph happy or unhappy? It's happy, yes. So the A value affects the shape of the graph, whereas this one, the shape of the graph would be unhappy. I said that informally, but basically if A is less than 0, it's unhappy. If A is greater than 0, it's happy. So that's the one thing that's different. The other thing that's different is that this one has a middle term. And so the initial parabola is actually shifted horizontally relative to like a normal parabola or the most basic parabola. Whereas this one over here, because it doesn't have a middle term, it stays anchored on the y-axis. But we'll get into that at a later stage. Okay, now, something else I want to mention is I could rewrite the green graph like this, and that means exactly the same thing. So that is the graph of f, where f of x is minus 3x squared minus 4x plus 7. This is exactly the same graph as this one, except we call this function notation. And what's nice about function notation is that you can label. So if you were drawing the graph, you don't have to write the whole equation. You can just write like f. And it also allows you to talk about things in the graph. So for example, if I said to you, what is the value of the f of 2? Could you work out what the f of 2 is using that description of the relationship? So find me the value of f of 2 and pop it in the chat. So how do we get this? What I like to do is make a space for where all the x's are going. And so let's have a look. That's minus 3 times 4 minus 8 plus 7, which is minus 12. So minus 12 minus 8 plus 7, which is minus 20 plus 7, which is minus 13. Okay, and it's important that you know how to use exponential notation, and you can sometimes even see exponential notation used with straight lines, and that's completely fine. And so I just need to make sure that you are comfortable with that. But it seems like you are, so that's cool. We're going to move on. Okay, I want you to tell me which of the following is an example of a quadratic graph. Now, a quadratic graph is the graph that goes with a quadratic equation. And a quadratic equation is something that has like a power of 2 in it, right? So that would be a quadratic equation. Which of the 4 options is going to relate to so I think because of the happy, unhappy thing, you can see that it must be A. Because it's that happy type shape. This is a straight line graph. This we'll talk about later. This is a hyperbola. It almost looks like it's been chopped in half. And this we only do in metric. This is called a cubic graph. But the one that we wanted would be a parabola. Okay. Let's do this one. This is part of a table, and it says there is a relationship that y equals x minus x squared. It then says that x is minus 2. What value, okay, will y take? So what value of y will go with when x is minus 2? I want you to tell me, is it A, B, C, or D? So I've got that situation going on. So I've got minus 2. Now, the thing that's going to catch you guys, if it does catch you, is that this is 4, in which case that is minus 6. And so that would be C. So with parabolas especially, if you have a minus x squared, right? If you have a minus x squared, remember, when you have a negative and it's squared, it becomes positive. So then if you have a negative in front, that whole thing then is negative. And so that's an important thing to be aware of. Our students often mess that up. And so I just want to do one example where I literally show you, watch out for when you square something, and if it's got a negative in front. Okay. Let's look at this one. here is the graph of y equals x squared minus 2x plus 1. What is the value of y when x is 2? Now, you can use algebra, or you can literally just read it off the graph. So you tell me which one you think it is. What is the value of y when x is 2? Is it A, B, C, or D? So when x is 2, visually I would see it here, and on the graph, it goes with 1. So I get 1. And just to make sure that algebra is telling the same story, let's just quickly check it. So if we had 2 here and 2 here, we would get 2 squared minus, oh, I left something out, minus 2 times x. Let me do that again. So that would be 4 minus 4 plus 1, which is 1. Okay, I'm going to change the question a little bit. I'm going to say this graph is actually the f of x equals x squared minus 2x plus 1. So that's the same graph. But I want to know, what is the value? We ignore this bottom part now. I'm making custom questions for you. What is the value of the f of 3? So as I look at this graph, f of x equals x squared minus 2x plus 1. What is the f of 3 equal to? Pop your answer in the chat. So here's 3, and this is the function f. So if this is the function f, let's see what happens when I put a 3 into this. It seems to be going with the value 4. So the f of 3 is in fact 4. Okay, so that's how you use function notation using a graph. What if I said to you, for what values of x is f of x equal to, how can I make this exciting? For what values of x is f of x equal to 1? So I'm saying for what, so you need to tell me what values of x is f of x equal to 1? And I want you to look at the drawing and see if you can figure out which one. You have to give me answers though. And it's values plural. So for which values of x is f of x equal to 1? I'll give you one tip. You could also say for which values of x is y equal to 1. That means exactly the same thing. So there's where y is equal to 1. So I draw a horizontal line, and I see where does it hit the graph. It hits it over here, and it hits it over here. And so the answer would be when x is 0 or when x is 2. So when x is 0 and when x is 2 is where this is the case. Give me a thumbs up if you understood that. Give me a thumbs down if you didn't understand it. Just want to get a feel for how everyone is finding that question. Okay, let me change the question slightly. We're going to do another version of this. For what values of x is f of x equal to 4? For what values of x is f of x equal to 4? And remember, sorry, I rubbed out f of x, but f of x was just, it's the same function we had here. So I'm going to take my horizontal line and I'm going to move it to here. And I see that it cuts the graph when x is 3, but also when x is minus 1. So x is minus 1 or x is 4. So not 4, is 3. And just to show you I'm telling you the truth with this, let's just put the f of 3 back into the graph. So if I go something squared minus 2 times something plus 1, and I make this 3 and 3, what I'm really hoping I get is 4. So let's see what happens. 9 minus 6 plus 1, so that's 3 plus 1. The good news is the maths and the graph are telling the truth. Now, students often find the back and forth between f of x notation and the drawing and x quite difficult. And so that's why I think going this type of route with the question is a good one. Okay, I'm going to give you a moment to take any screenshots you want or to ask any questions. Just pop your hand up if you have a question. Otherwise, I'm going to move on. We'll do one more before our halftime break. Okay. Maybe we'll squeeze in 2 more if you guys do this one quickly. Okay, so this is a graph of a parabola, and there are possible equations that could relate to this over here. Which of the 4 options do you think describes the parabola over there? So I would advise you to look, what are the x-intercepts? What are the y-intercepts of this graph to try and help you on your journey? So what I've realized is this doesn't cut the x-axis. So actually, there are no x-intercepts for this. But now when I look at the y-intercept, what I do notice is that it's above the x-axis. So that helps me understand that this must be a positive value. If I was guessing, maybe it's like +2 or +3, or who knows, but it must be a positive y-intercept. So the ones that have no y-intercepts or have 0 y-intercepts, then they can't be ones. So then the only option that makes sense can't be a -3, because a -3 would look like that. So the only one that works is that one, in which case this would be, that has to be a +3 to give you that. And so it would be D. Okay, so that is a little bit of a recap of straight lines and a little bit of an introduction to parabolas and functions. After the break, we're going to do some more exposure to the 2 other main functions that we deal with in this topic, exponential and hyperbolas. We're just going to do what we've been doing now, just getting familiar, and then we'll also talk about intersection points if there's time. But to make sure that we get the most out of our time together, we have to take care of our bodies. So let's all just stand up for a second. And let's just roll our necks a little bit. And maybe stretch to the one side. Stretch to the other side. Then what I want you to do is put your arms out and just roll from one side to the other like this. Nice and relaxed. Oh, I can hear my back clicking. And as you relax, you'll feel yourself going further. I can feel how much looser my back is now after the spinning. Okay, so I feel a bit looser in my back. Let's roll the shoulders back. Just a little bit. Roll the shoulders forward. Okay, let's shake out the arms. Shake out this arm. If you shake out both of them, if we can. It's like you're drying your hands, you know, like you shake your... And then let's shake our legs. I'm definitely feeling more relaxed after doing this. And then let's just get some blood flow in our bodies. And the quickest way I know to do that is a jumping jack, and we're going to do 12 of them. So let's go. 2, 3, 6, 7, 8, 10, 11, 12. And that is our break. But let's just do a little puzzle to give our brains a chance. There we go. Brain break. So who knows who these guys are? Or today's puzzle, courtesy of cartoons from the past. They are the Ninja Turtles. Yes, these guys were quite big in my childhood, but clearly they're still around if you know who they are. So the first Teenage Mutant Ninja Turtles, I think that is Michelangelo or Mikey. So what is Mikey worth? Okay, it is 22. Yep, 22. Because that's the only way you would get to 66. Now, you can't really do the second line because there's two unknowns, but what is a piece of pizza? And I'm pretty sure Mikey quite likes his pizza, if I'm remembering the story correctly, hence the pizza. Yeah, it's actually not that hard because the pizza must be 2, because if this is 22 and that's 11, that's half. So the only way you get half is by doing a 2. But now what does Raphael have to be then to get a 0? The only way you get 0 multiplying by a positive number is if that number is 0 itself. So what is the final answer going to be? Well, they're just being added, so it can only be 24. Yeah, so that was kind of easy. But well, it wasn't that easy, but yeah, the last part was easy. Okay, so we are going to return to our lesson, and I want to look at a graph like this. So what type of graph? Now, this definitely is not a straight line. It's definitely, well, I suppose it looks a little bit like a smiley face, but it looks a bit more uneven. What type of function is this? It is indeed the exponential function, yes. The exponential function, it kind of looks like a roller coaster or something that took off. It starts slowly and then just takes off. And often it models population growth or disease infections. It describes that behavior quite well. Now, the thing that stands out about an exponential function is that the variable, the input variable, is a power. So I'm not sure you can all see that, But the function they say here is y equals 5 to the x, or if I was using function notation, I could also say g of x is 5 to the x. And it says, as the x values increase, so as the x values increase, what happens to the values of y? Is it A, B, C, or D? What do you think is happening? It's kind of visually, you can kind of see. So the people have spoken, and the people say C. And if I look at this, you're quite right. As x is getting bigger, what we notice is y is just taking off, and it is not coming back. So what's going to happen is it's getting larger and larger, and it's just not coming back. So it's taken off. So as x gets bigger, that gets there. The other thing that's interesting about the exponential graph like this is that it doesn't cut the x-axis. Or at least not in the current form, it doesn't. So that's interesting. Okay, let's do another one that's somewhat like this. So, sorry, the print obviously clipped these at too low a resolution because it's a little bit blurry, but it says, I'll read it with you. Here is the graph of y equals 3 to the power of x. As the value of x decreases, so as the value of x gets less, it goes to the left. The values of y get what? Is it A, B, C, or D? Pop your answer in the chat. So we can kind of do a little experiment to see what's happening. Like on your calculator, you could put x's, so you could get a third. And then if you said y equals 3 to the minus 2, you would get 1 over 9. Okay, so when you put a minus 1 into the graph, you get a third. When you put minus 2 in, you're getting a ninth. Now, it does, if you put that into decimal, you will see that it's getting smaller. There's no doubt it's getting smaller, right? So it's getting smaller and smaller, but I don't ever see it cut the x-axis. So it can never become negative, because even though it's getting smaller and smaller and smaller and smaller, it never jumps across the road. So even though I understand why a lot of you are saying B, it doesn't actually ever get negative, because if you look at its y value here, it's still like 1 over 3 is a fraction, but it's still positive. 1 over 9 is a fraction, but it's still positive. If I put a minus 3 in here, I would get 1 over 27. And that's really small, but it's still positive. And so it's smaller and smaller, but it's actually going to be A is the answer. Give me a thumbs up if you understand why that one was a sneaky one, but you understand why it's A. Give me a thumbs down if you feel a bit lost. Okay, did I lose you there? Let me draw it for you as well. Maybe I can do it that way. So, okay. If I was drawing the graph of y equals 3 to the x, that's what it looks like. And on this side, you will notice that it never actually cuts the x-axis. It just keeps getting smaller. Like I think the first one, when we said x was minus 1, we got 1 over 3, right? When x was minus 2, then we got 1 over 9. When x is minus 3, it's going to be some really small value down here. But it never ever gets down here. The y value never becomes negative. So it just keeps getting smaller and smaller and smaller and smaller forever. But it never becomes negative. So that's why it can't be b, because even though it's getting smaller, it never actually is negative. It stays, it's positive throughout. It just gets smaller and stays positive. Okay, give me a happy face if that helped. Give me an unhappy face if it didn't help. A bit. Don't worry, you can re-watch this part. We're going to do a whole lesson on exponentials later on. So don't stress if that's the case. Today is just introduction day. I'm just introducing you to our new friends. Don't worry, Amelia. I'm going to help you in this next one here. So we have an exponential function again. It's got this feeling of just taking off. They tell us that the equation of the graph is y equals 3 to the x. And then they want to know what are the coordinates of the point marked P. So to me, that looks like a y-intercept. So be aware that looks like a y-intercept. Which of the 4 points do you think represents P? So this is a coordinate, so it must have 2 coordinates. What do we think the x coordinate of the point P is? What do we think the x coordinate of the point P is? It's 0. Yeah. Because it's in line with x is 0. So it can't be C and it can't be D. So is it going to be A or is it going to be B? That is the question, ladies and gentlemen. All right. I'll tell you what, let's use the equation of the graph to help us. When x is 0, what is the y value that goes with that? What is 3 to the power of 0? It must be 1, which means that must be 1. And this point over here, its y-intercept is, in fact, is 1. So the coordinate there is 0, 1. Now, just to be a little bit sneaky, well, not sneaky, but just to make life a bit more exciting, I'm going to take this function f of x equals 3 to the x, and I'm going to upgrade it, and I'm going to say to you, what is the value of the f of 2 if the f of x is 3 to the x? What is the value of the f of 2? So the f of 2 is just going to be 3 squared, which is 9. Okay. I want to know what is the value of the f of minus 2. So following this rule, it would be 3 to the minus 2. But now from our knowledge of exponents, can't we change that to 1 over 3 squared, which is 1 over 9? So visually, let's even look at the graph and what this is. Basically, what it's saying is that when this is 2, the value it would go with is, now I know it's not very nicely to scale, but if f of 2, this would be 9, whereas f of minus 2, let me make it a little bit better to scale, is going to be a really small number over here, which is 1 over 9, or 0.111, something like that. So we can see how we say that it's decreasing to the left and it's increasing to the right. Okay, let us have a look at this one. So which of the following is most likely to be the graph of y equals 4 over x? Now, to point out, this is not a parabola because there is no power of 2. This is not an exponential function because there is no variable power, which is an x. And it doesn't look like a straight line, which would have that format. So which one of the graphs? It's not the straight line, it's not the parabola, and it's not the exponential. So it must be A, and the name of A is the hyperbola. Now, why is the hyperbola look like it got cut in half? Because it literally did. There's something called an asymptote, which runs here, and it divides the graph. And there's another thing, another asymptote over here, which divides the graph. And the reason this is happening is that we may not have a value of 0 in this type of function because it would cause division by 0. And we're not allowed to do that. So literally all we say is, this is a no-go area. And the reason there are 2 of them is you could rewrite this equation as 4 over y, in which case y cannot be equal to 0. So both of these values are undefined, so we literally block them off. And those are called asymptotes. And so that's a hyperbola. And that's another shape that we need to get familiar with. So let's see. I think you can do that one already. Okay. Let's try and understand this graph. Here is the graph of y equals 5 over x. As the value of x increases, so as the value of x increases, visually, I'm going in that direction. Oh, wait, it says as the value of x increases in size in the negative direction. Oh my gosh, I made it up. Sorry, everyone. Did you see that second part? So as the value of x increases in size in the negative direction. Oh my goodness, they're being so sneaky. So the negative direction, increasing in size in the negative direction goes here. What is happening to the value of y for this graph? That almost caught me. So as I'm going to the left, what is happening to the size of the value of y? We can try this out. So here's like an x value. Well, actually, here's an x value, and that's the y value. Here's an x value, there's the y value. So I'll show you what y values you're getting each time. If you're going to the left, you could be there, and then that would be there. I think if that was the first y value, and that was the second y value, and that was the third y value, what is happening to these y values? Are they negative or positive, and are they getting bigger or are they getting smaller? So for me, the y values are getting bigger, but they are in a negative part of the world. So if I look at where they're hanging out below the x-axis, so they are negative, but they are getting bigger and bigger and bigger if I'm looking at this side over here. If I'm looking on this side, so I'm going in the negative direction, then that would be, y would get bigger and stay negative. If I was on this side, so if I was on the other side over here, it would be say y, as y gets smaller, sorry, as x gets smaller, y would get bigger. But that would be on this side. On this side, y would get bigger, but it's staying negative. It was a little bit of a confusing one. And I think the reason it was confusing is the wording is a bit weird. So I don't want you to stress about that, because even for me, I was like, huh, what are they asking? And it's mainly because the wording is too detailed. So I don't want you to stress about that one. I want you to just ignore, like, we can write that one off if you're feeling confused. Okay, here is the graph of y equals 4 over x. What is the value when x is equal to -1? What is the value when x is equal to -1? What do you think the answer is going to be here? Where is -1? There's -1. So I'm going down. And if I go across, it looks to me like I'm in line with -4. So my answer would be -4. But I can also use algebra to put the x in, and I also get -4. So that makes me rather happy. So the answer is B. Now, just to upgrade this question for a second, what is the value if I said to you, f of x is 4 over x? What is the value of the f of 1? What is the value of the f of 1? What's that going to be? Visually, it looks to me like it's 4. And algebraically, I can find it by just going 4 over 1, which is 4. And so both these answers make sense to me. Okay, let's see if we can find one more question. Okay, last thing we're going to do for today is when we have two functions. Now, these are two straight line functions. We often have to find where two functions cut each other, right? So I don't even know if these are the correct things, but we need to know the process for finding the intersection point. So that's one type of intersection point. Another question that comes up more in grade 11 is what happens if a straight line, where does a straight line cut a parabola? So what I want us to do is I'm going to do the first one, the straight line one, and then you're going to do the second one. So let me just show you how we do that. Whenever you want to find the place where there are intersection points, where two functions meet, all you want to do is solve them simultaneously. So really, you treat it as a simultaneous equation to find intersection points. The method I like for most simultaneous equations is take the easy one, in which case it's this one, and sub it into the hard one. So I'm going to say x plus 2 times something plus 3 equals 0. And the thing that I'm subbing in is the easier equation, which is going to be this one, 2x plus 1. Then what I do is I multiply that out. And I'm going to get x plus 4x, so I get 5x plus 5 is 0. I get 5x equals -5, and then I get x is -1. But that is not the simultaneous solution. I still need to get my y value, and my y value I get by taking the easy equation and timesing it by -1 plus 1. What do I get there? -2 plus 1 is -1. So the point of intersection between these two straight lines is x is -1, y is -1. So that's something you did in grade 10. Now, I want you to find me the intersection points between these two functions. The only thing I'm going to do to help you is I'm going to rewrite this in conventional notation so that you guys, maybe it's easier to understand the connection. So I want you to find me the intersection point or points. And it makes sense that there might be 2 points because if a parabola looks like that and a straight line looks like this, I would expect there to be two answers. So I want you to find me the answer to where these two functions meet using the method I just showed you, and then we are done for tonight. I would start by doing that. So I've got to solve this equation. What I'm going to do to make my life a little bit easier is I'm going to bring everything to one side. And let's make sure I've done this properly. X squared minus 3x minus 2x minus 3. It feels like this is going to be a messy answer, so I'm going to use the formula. Okay, p squared. So that's going to be 25. Okay, so I get the answer for x being 5. Maybe you can help me with the decimal, but one of them is going to be 5 plus square root 29 over 2, or the other one is going to be 5 minus square root 29 over 2. What are the decimal values you get for that? Okay, maybe I should just leave them as that for tonight. We're running out of time. So essentially, we've got these x values, and all I need to do to find what the y values are that go with them is sub these x values, whatever they may be, back into this equation. And that's how you will get the x, the places where they intercept each other. Now, that might have been a little bit quick for the end of the lesson, so